Thanks for tuning in. This is Astronomy 101 Part 2. I call it 101 because it is going to be pretty basic. I have had requests to do more in-depth and more conquer more difficult astronomy material, but I wanted to finish my 101. And so I have this bag with some books in it. And of course, at the end, there is a space article in this National Geographic that I will flip through for you. So, last time I made a video, we discussed basically the Big Bang theory, the formation of our solar system, our sun, the planets. I talked in depth about those planets, and in this video I'm going to discuss stars, nebulas, black holes, pretty much all the other astronomy basics. Okay, so let's just do a quick review from 101, the part 1. I'm really sorry about the noises upstairs. There's not really a time of day that they're quiet. But I will be moving soon. So basically there was some form of energy that had some sort of Big Bang caused it to, unknown energy, a massive blast caused it to form elements, and the universe expanded in a very, very large rate of speed, and it is continuing to expand. And scientists believe this because there's leftover cosmic radiation, cosmic microwave radiation, and plasma that they are able to determine that other galaxies are expanding exponentially from us, from our galaxy. So there were pockets of elements and dust and energy, and these formed in our particular solar system, our sun. And then what was left over after the hydrogen formed into the sun became the leftover debris, and whatever became our planets. So that is in a more or less what we talked about in part 1. So there are some potentially 100 billion galaxies in our universe. Within our own galaxy, there's 500 solar systems. So there are other planets and suns within our solar system. Within our galaxy. Most of what scientists study and most of what we see with our naked eye is within our galaxy. And scientists, in order to determine how far away things are, they measure things in light years, and that's basically how long light travels in a year. I don't know the exact equation for that, but I'll find it for you. Let's see. distance light travels in 1 year is 186,272 miles per second, broken down by 365 days, 24 hours a day, 60 minutes, 60 seconds, nearly 6 trillion miles. Our own sun is about 156,000 miles away. Takes about 8 minutes for our own sun to reach us, for the light from our own sun to reach us. So, comparatively a lot closer. So, how do astronomers study stars? They use objects, can be observed with radio telescopes. Warmer objects, they use infrared radiation, ultraviolet radiation, and X-rays. And they basically use absolute versus relative brightness of the stars. And I'm going to show you a chart. The brightest stars seen from Earth. And I'm not going to go into much more detail about how scientists have determined how far away other stars and galaxies are, and how they measure the luminosity of the stars, and how they determine how large they are. That's a complicated astronomical field that maybe I'll tackle in another video. I'm just going to stick to the very basics. I apologize for anyone looking for more in-depth material, but we can always tackle that some other day. Okay. So, let's talk about what stars are basically made of. As we discussed in part 1, our own sun formed from a nebula, which is basically means cloud. It was a cloud of gas, mostly hydrogen. And so that's how all stars form, is with clouds of hydrogen. And then when the hydrogen it circles through space and cosmic dust, and the gravity will eventually cause it to condense, and it'll start spinning faster, and as it condenses there's more pressure, it's spinning faster, and the hydrogen starts to fuse its protons and turn into helium. This is called nuclear fusion. It is exothermic. It creates a lot of energy. So stars, young stars, protostars, are start to undergo this nuclear fusion, and then this energy causes them to start to emit light, and they can become bigger, really big in some cases. Our star is medium-aged, relatively medium-sized star. Let's see, it's been burning for about 5 billion years, and it will continue undergoing nuclear fusion for 5 billion more years until it simply runs out of hydrogen. And this is the case with most stars. And I'll show you a picture. The course of our star and other stars. after it undergoes nuclear fusion for billions of years, this is our sun, okay? It'll start to cool in the center, and it'll shrink a little bit. It'll shrink inward a little bit before the material causes a mild explosion. The star will then turn into a red giant. So it kind of like starts to fizzle out and collapse inward a little bit, and that causes it to have one last burst of energy. And this can give off a planetary nebula. We see other stars that have planetary nebulas around them in the solar system. This does not have anything to do with planets. It's just called that because it's shaped like a planet. It's round, the area around the sun. And that's what this is. This is a planetary nebula. This is what happens to the stars. And it's just basically a spear of gas bursting from the surface. And then after that explosion of gases and energy, its final last hurrah, it'll burn out, but this time it'll just condense into a white dwarf. Some stars that are smaller than our sun in our solar system are small enough that they don't turn into a red giant first. They don't even have enough energy to do that. It will just simply turn into a white dwarf. Some stars, though, supergiant stars, they burn so fiercely that at the end of their life, there is a supernova explosion. And we actually had a star do that in our galaxy that was observable like 10,000 years ago or something like that. And I think I think the Greeks, they saw it for like 3 days. There was this explosion in the sky that they witnessed, and then it turned into what we know as the Crab Nebula, which is clouds of gas left over from that star. So, or it can turn into a pulsar, or it can turn into a pulsar or a nebula or a black hole, and I'll talk about that in just a moment. So that's what happens. Now, stars that are, usually they're about 8 times larger than our sun, do this, and they have much shorter lifespans because they burn through their hydrogen much more quickly and fiercely, and just they're much more violent in general. And so because I'm going to talk about nebulas next, I wanted to note the Crab Nebula, but we'll get to black holes later. My hamster's awake and he might start chewing on his cage, and I may have to go remove him from the room. He looks like he wants to come out and play. Okay. Galaxies have hundreds of billions of stars. Yeah, he's getting testy. I'll be right back. So there's a balancing act with stars. How it dies depends on how it lived. Gravity constantly pulling the gas into the center of the star, but energy from nuclear fusion expelling that back outwards. So it is a balance. So when it runs out of hydrogen, things are going to happen that when that balance is suddenly off. Okay. Let's look at there are planets, other planets around other stars in our solar system, and stars are easier to study obviously because they emit light. Planets, that is very difficult because the only way that scientists can really see other planets sometimes is when there is the teeniest shadow of a planet orbiting another star, and it is so minuscule that only very, very large special telescopes and things can read and register that. Scientists have also noted that in other solar systems they can see a little bit of a gravitational pull on some of the stars, and they can kind of tell by this pulsing of certain stars that there is a planet nearby, or planets. So when I talked about our solar system and our planets, I didn't talk about planets in other solar systems or how many solar systems were in our galaxy, but I did want to note that because I think that is amazing that there are at least 500 other solar systems within our galaxy, and many containing other planets. I just think that's really cool. Hundreds of billions of stars, and scientists have even been able to see other galaxies and study other galaxies now with some of the instruments that we have. That's just amazing. So let's talk about nebulas, and then we'll talk about other galaxies. Okay. So as I noted before, nebulas are basically interstellar clouds of dust, hydrogen and helium and other ionized gases. Okay, so you can have a supernova nebula, which is what the Crab Nebula is. And I actually have a picture of that in the National Geographic that I'm very excited to show you guys. And basically it's the remnants left over from a supernova explosion. Emission nebulas are basically clouds of high temperature gas nearby. They can sometimes give birth to stars. So our sun came from an emission nebula. And we talked about planetary nebulas, which is when a star like ours enters into the red giant phase, and there's like a shield of gas around it that basically it's a cloud of gas. Some nebulas are referred to as dark nebulas, and that is because basically the cloud of gas is in front of a star or constellation or whatever, when we see it like a dark mass in front of something and we're like, okay, and that's a cloud of gas blocking this star. That's a dark nebula. But it can also be behind a star, and then that's when it becomes very beautiful, because the gas emits different colors depending on whether it's reflecting or diffusing. So a reflection emission nebula will appear blue because they scatter light, and a diffuse nebula will appear red. So it's pretty awesome. Let me see if I have any pictures of nebulas in this book for you. Okay, so this is just showing an example of a basic nebula. It says it's a place where dark dust lanes obscure some of the light behind it and where new stars are forming. So, you can have several stars form from one nebula. You can have a star and planets form from a nebula. Just depends. So here's a dark nebula blocking light behind it. here is a planetary nebula. Okay. Just wisps of gas that are observable. They're beautiful, very beautiful. Okay. So when large clusters of stars form and they're kind of gravitationally pulled to each other, those are known as globular clusters. Small clusters of millions of stars, and yeah, I don't know if you've heard that before. I'm not sure if I have any pictures of that. A pair of star clusters is here. Okay. And then this is a starburst galaxy that the Hubble telescope saw. Basically a galaxy with a bunch of stars forming quickly in a small area. You can also have a galactic cluster. It's different than a globular cluster. The stars, like the Seven Sisters constellation, they're loosely tied to each other, but not as much as in a globular cluster. Now we're going to talk about black holes. Right. Basically, a black hole occurs when a star that is more than 10 times larger than our star after a supernova explosion, there's a core left over, and it may be massive enough to shrink even smaller than a neutron core. So it is so heavy and dense that it folds in on itself, and the stronger the gravity, the more force pulls stars' outer layers inward. So it basically collapses on itself, and it is so dense that the gravitational pull from its own center just envelops it, and it envelops things around it. So this is really one of the only ways scientists have been able to study black holes, is basically how planetary and other interstellar things are behaving around a black hole. Light and whatever it might be, they can kind of tell that there's a point of no return known as the event horizon, that once light reaches this, it's like sucked in and it does not come back out. Astronomers and physicists do not know what happens inside of a black hole. They think that potentially the laws of physics as we know it don't even apply. They really have no idea. Matter basically collapses into infinite density. And yeah, no one knows exactly what's going on. But we can see the effects on nearby matter, and they're trying to determine, they're trying to make new instruments to measure them. So there are black holes in our galaxy. There are nebulas in our galaxy. There are other planets in our galaxy. Almost everything we can see with our eyes in the night sky is found in our own galaxy, the Milky Way. Astronomers have discovered that we are in a galaxy shaped like a pinwheel of about 200 billion stars. Large numbers of nebulas and star clusters, globular clusters, galactic clusters, and uncounted planets. It's a spiral-shaped galaxy, as we discussed. There are also elliptical shaped galaxies and irregular shaped galaxies, which is most likely the cause of two galaxies colliding. Andromeda Galaxy is coming towards us instead of away, so eventually we will collide with that galaxy. Now I'm going to read to you something called dark matter, and then we're going to look at some pictures. Okay. Oh yeah, other solar systems, they have usually our star is a main sequence star, but as I think I noted in the first video, there are star systems, solar systems that have that are called binary systems. I forgot to mention that, so now I'm going to read to you about dark matter. Okay. If this matter is invisible to us, why do astronomers think it's there? We can measure the motions of galaxies, galaxy clusters, and giant superclusters of galaxies. The speeds at which the Milky Way and our nearest large neighbor, the Andromeda Galaxy, are rotating demand some outside, unseen matter to create a force of gravity. They're moving fast enough relative to each other that they would simply fly apart if it were only the gravity of the matter we can see that is working to hold them together. There has to be some other force. We just don't have enough visible matter to account for the gravitational forces affecting them. Astronomers call this dark matter. It makes up 90% of the universe. What we see is only 10%, scientists believe. So there's still so much unknown. I wanted to show you some constellations. I don't have much time now, but I do want to show you a couple of my favorite. I'm going to look. Okay. Orion. In the January night sky, you will see Orion, which is shaped like a great hunter. 3 bright stars in his belt, nearly in a straight line. And it looks, it's supposed to look like this. Okay. It's part of the Orion Nebula. And another nebula that's cool is the Horsehead Nebula. It's a dark nebula, and there's like a shadow in the shape of a horse head. And that's also visible in January. And then, of course, everyone is familiar with this, the Big Dipper, which makes up Ursa Major, or the Great Bear. It contains 7 stars of the Big Dipper, visible in March night sky. And the Little Dipper, or Ursa Minor, it contains at the tip of its tail the North Star. So that's how you find that, is by finding the North Star. And that is most visible in March as well. So I'm sorry I don't have more time to delve into constellations for you, but I also wanted to talk about solar eclipses and lunar eclipses. So I'm going to whisper to you, and then I'm going to show you some cool pictures. Solar eclipses happen every year during new moon phases when the moon passes between the Earth and the sun light becomes blocked. There are about 2.4 solar eclipses every year. A lunar eclipse, or the red moon, is when Earth blocks sun's light from reaching the moon. Some of the sun's light passes through the Earth's atmosphere, though, just enough to refract and hit the moon, but it removes the blue coloring and leaves the moon red. This happens 0 to 3 times per year. The next lunar eclipse is projected to happen September 28th, 2015, and you should be able to see it from America, East Pacific, Europe, Africa, and West Asia. So, pretty cool. Now, I'm going to adjust my lens for a viewing of this National Geographic. Just bear with me. Let's see, maybe if I just move it this way. I'm sorry. Okay. Let's find it. Article about Lincoln. If you saw my president's video, you will know that I was a fan of his. Here we go. Hubble's greatest hits. So basically, this issue talks about picture that they asked one of the scientists to tell which of the photographs the Hubble telescope took were his favorite. Cosmic fireworks. Sparkling with energy, a cluster of young starlights up a cavity in the roiling dust of the Tarantula Nebula. This is one of his favorites. He says stars are being born, stars are dying. There's a vast majority of energy churning. This is a look at the Horsehead Nebula from the Hubble telescope. The nebula normally appears dark against a bright background, but Hubble penetrates the shroud of interstellar dust and gas to get this different view of the Horsehead Nebula. These are 2 different galaxies. Can you believe that we have an instrument that can show us this? This is so cool. The galaxy known as ARP 273. 2 spiral galaxies in a galaxy cluster known as ARP 273. They're preparing to merge 300 million light years away. It's crazy because sometimes what we see from other galaxies is we're basically seeing something that's 1 billion light years away, meaning it took 1 billion years to reach us. And by the time we see it, that galaxy has changed. We're seeing that galaxy 1 billion years ago by the time a star that's 1 million light years away reaches us, we're seeing what it looked like a million years ago. When you look at the stars in the sky, you're looking at, you're looking back into the universe. It's so cool. This is basically the Andromeda Galaxy. And this is gas from a dying star resembling a butterfly. It's a planetary nebula, which is what happens when a star starts to die and then it starts to emit gas. This is an expanding planetary nebula and star. That is so cool. This is the Carina Nebula. It's beautiful. Very beautiful. Galaxy NGC 1300. There's not a picture of the Crab Nebula. I thought that there was. I'm so sorry. You can look it up online. It's there. It's a very popular one. So, thank you guys so much for watching. And I hope that this was sufficient in a follow-up to my first one. If I'm able to make a more in-depth astronomy video, including things about how astronomers measure things, quantum physics, things like that, I may tackle